Oh, here is a nice limit problem with radicals. So if this gives me an indeterminate form, 0 over 0, I'm immediately thinking about what my plan B will be. And I know I'm going to introduce conjugates. Let's see. If I put in a 3, I get 3 minus 1 minus the square root of 2 over 3 minus 3, which is root 2 minus root 2 over 3 minus 3. Guess what, youngsters? We have this indeterminate form, which means we have a hole. Where? I know at least the x-coordinate of the hole is that x is going towards 3. Now, if I have radicals, I'm thinking about a plan B that involves conjugates. The square root of x minus 1 minus the square root of 2 over x minus 3. I'm going to introduce conjugates of what? Well, the numerator has 2 terms. So my first term, x minus 1, my last term, square root of 2. If this is a minus, the conjugate will be a plus. And I'll be multiplying those out, but I have to introduce a fraction equal to 1. So I have to mirror what's in the numerator with what's in the denominator here, x minus 1 plus root 2. Remember, the magic of conjugates is that the oi of FOIL cancels out. Square root of x minus 1 times square root of x minus 1 is the square root of x minus 1 squared, which is simply x minus 1. A negative times a positive is a negative. Square root of 2 times square root of 2 is square root of 4, which is 2 over x minus 3 times the square root of x minus 1 plus the square root of 2. Now, I leave this as multiplication. I don't FOIL the bottom because I'm trying to cancel something. Well, this is going to be the limit as x approaches 3 of x minus 3 over x minus 3 times the square root of x minus 1 plus root 2. And if these have been good little x minus 3's, we cancel. Notice x minus 3 over x minus 3 is 1 over 1. They don't cancel to 0 to give us limit x approaches 3 of 1 over the square root of x minus 1 plus root 2. And now, after we cancel, we're ready to try to do direct substitution. 1 over 3 minus 1 plus root 2 gives us 1 over root 2 plus root 2 is, well, there's 2 of them down here. 1 over 2 root 2. And there is your limit. There it is. There's the answer. That's the trend in y. That's where y is going to or trending to as x squeezes in from the left and right on 3. So, of course, your hole is found at 3 comma the y value. And I'm not going to bother to rationalize that. But this is a bonus. The hole is the bonus. This is the answer, the y coordinate of your hole in this case. With any limit problem, my plan A is to use direct substitution. So I put a 0 in anytime I see an x. 3 minus the square root of 0 plus 9 over 0. This gives me, it didn't work out. I'm always having my hopes up just in case it does work out. And so I'm going to write this as limit x approaches 0. Whenever I see a radical, I start thinking, maybe I could use my conjugate technique. I'm going to introduce 3 plus the square root of x plus 9 over 3. Let me see that. That's 3 plus the square root of x plus 9. Notice that's a fraction equal to 1. And when I have conjugates, I love conjugates. Why? Because when I FOIL, F-O-I-L, as I will in the numerator, I don't have to worry about the inners and outers. So just first is 3 times 3. That gives me 9. And last, negative times positive is negative. The square root of x plus 9 squared is simply going to be x plus 9 divided by x times 3 plus the square root of x plus 9. Now, I might be able to cancel something here, so that's why I keep it as multiplication at the bottom, because I can only cancel across a multiplication sign. Well, if I distribute out this negative, we've got to be very careful. This was the opposite of the square root of x plus 9 squared, which is the opposite of x plus 9. Gives us the limit as x approaches 0 of 9 minus x minus 9 over x times 3 plus the square root of x plus 9. Well, if these been good little 9s, they go off to number heaven, and we're left with limit x approaches 0 of the opposite of x divided by x times 3 plus the square root of x plus 9. Well, because we have multiplication here, we can cancel these, but they don't go to 0. It's x over x is 1, or 1 over 1. Limit x approaches 0. This is the opposite of 1. Don't forget that negative. Over 3 plus x plus 9 in the root. And now, after we've canceled, perhaps direct substitution will work. Negative 1 over 3 plus the square root of 0 plus 9 is, the square root of 9 is 3. So this is going to give us negative 1 over 3 plus 3, negative 1/6. That's where y is heading. So this is our limit. And we knew there was a hole. As x approaches 0, y is approaching or trending towards negative 1/6. 0, negative 1 over 6. There's bonus material. That's where the hole is located. It's an xy point. So there's our hole. Remember, we're going to have a y with the hole. And the y is the limit in this case.